Hi, today we're talking about CCM8, Unit 4, Lesson 3, multiplying numbers in scientific notation. So, Vic number 1, that stands for a very important concept. When multiplying numbers in scientific notation, use the associative property of multiplication. That means you can rearrange the order of, and the grouping of your multiplication so that you can easily multiply the numbers together. Vic number 2, after multiplying numbers in scientific notation, make sure your answer is in scientific notation. So to do that, you will need to either move the decimal to the left or to the right. If you move the decimal one place to the left, add 1 to the exponent. If you move the decimal place one space to the right, subtract 1 from the exponent. This is, even if your exponent is negative, still do this. You're going to have to add and subtract based on where you move the decimal. You're going to keep the number, it's going to be equal in value to your answer. It's just going to be in the correct scientific notation form. So always remember, if a number has no exponent, then it's understood that its exponent is 1. For example, if you have 10, that's really like having 10 to the first power. So here are some examples. 7 times the quantity of 7 times the quantity of 4 times 10 to the 5th power. What we can do is I can actually multiply 7 times 4 and then hold my 10 to the 5th power and put it in my problem at the end. That's so I can easily, 7 times 4, that's 28. And then so I've already jumped to what my final answer would be, 28 times 10 to the 5th power. But 28 times 10 to the 5th power is not in scientific notation because 28 does not fit in that range of a number between 1 and 10. So I've got to move the decimal so that it will become a number in between 1 and 10. So in a whole number, my decimal place is right here, and I'm just going to move it once to the left, which means I add 1 to the exponent. Again, I'm not changing its value, I'm just changing its appearance so that it will now be in scientific notation. So my new answer is 2.8 times 10 to the 6th power. One way to check your work to see if you did it right is to change this number in standard form in your calculator, or type this into your calculator and see if they match up. All right, here I've got another one. 0.5 times 1.2 times 10 to the negative 3rd power. So again, I'm just going to actually regroup my numbers using the associative property and multiply 0.5 times 1.2. That gives me 0.6. And then I've got times 10 to the negative 3rd power with my problem. Again, this number here, 0.6, is not in scientific notation. I need this to be a number in between 1 and 10. So I'm going to have to move the decimal. Move the decimal one place to the right, and I'm actually going to subtract an exponent so that I did not change the value of my answer. I'm just changing it so it's the correct answer. So I have 0.6 and I moved the decimal, so now my number is 6 times 10. And then negative 3 take away 1 is actually negative 4. So this is my final answer, 6 times 10 to the negative 4th power. All right, here we've got a number in scientific notation times another number in scientific notation. So what I'm going to do is I'm going to do the same thing. I'm going to regroup what I'm multiplying. So instead of 8 times 10 squared times 1.7 times 10 to the 4th, I'm going to multiply 8 times 1.7. That gives me 13.6. Then I regrouped my powers. And remember back when you did your exponent rules, when you multiply 2 powers, when you multiply 2 powers with the same base, you're going to add their exponents. So this 10 squared times 10 to the 4th now becomes 10 to the 6th. But if you look, 13.6 is not in my range that I need. So I'm going to move the decimal one place to the left, and I'm going to add a number to my exponent. So my final answer, 1.36 times 10 to the 7th. Why don't you pause the video here, try this last one on your own, don't look at the answer, and see if you get what we get. So, what you have here is 9 times 2.5, and then I put the powers together, 10 to the negative 3rd times 10 to the negative 5th. 9 times 2.5 is 22.5. 10 to the negative 3rd times 10 to the negative 5th, I'm going to add negative 3 plus negative 5 is negative 8. But I've got to move this decimal one place over to the left. So I'm going to add. And here's the kicker. Negative 8 plus 1 is negative 7. Hopefully when you did this on your own just now, you got this. We're going to do one quick word problem and then we're done. In 2005, the population in the United States was about 2.87 times 10 to the 8th power. Spending for healthcare was about $5,745 per person. About how much did the U.S. spend on healthcare in 2005? Use scientific notation. So here we're spending over $5,000 per person. So for every person here in the United States, that's how much they're spending on healthcare in a year. So we're going to multiply because we want to see how much the entire United States spends in total or in all. So I've got 5,745 times 2.87 times 10 to the 8th power. Again, I regrouped my numbers, so I'm multiplying my two numbers here, and I'm just leaving my power at the end. But look, I've got 16,488.15 times 10 to the 8th. That's definitely not in scientific notation. So I've got to move this decimal 1, 2, 3, 4 places to the left, which means I add 4 to my exponent. My new answer that is in scientific notation is 1.64885 times 10 to the 12th power. So this is about how many dollars the U.S. spent on healthcare in 2005. All right, hope you followed closely along with what we did.